this example, you are asked to prove the Laplace transform of t power of 2 equals to 2 per sine power of 3. In fact, in order to get the solutions for the Laplace transform here, you may refer to the table of formulas of Laplace transform. However, these questions ask us to prove the output by using the first principles. The formulas for the Laplace transform is given here. Substitute t squared into the functions of the formulas, and you will see that you need to do an integrations of two functions in the form of multiplications. To solve this, you have to do the integrations by part. Take u equals to the t squared, while the remaining, which is e power of negative st and dt, will be the dv. With the u here, differentiate it to obtain du, and with the dv here, integrate it for you to get the v. Substitute the value into the formulas of the integrations by part. u, v, v, du. Rearrange the functions, you will get this. There will be another layer of integrations, and these integrations involve multiplications of two functions of t. You will need to do the integrations by part again in order for you to integrate this. Let u equals to t, and the remaining will be the dv. Differentiate u to get du, and integrate dv to get v. Substitute into the equations for the integrations by part, which you will get u, v, v, du. The integrations of these functions will give you this. Substitute the output into the function here. Rearrange the functions, you will get this. There will be one more level of integrations. With that, you integrate this, you get this. Remember to incorporate c. Rearrange the functions, you get this. Based on the output here, you know that integrating this will essentially give you this with a boundary conditions of 0 to infinity. Substitute the upper boundary into the functions to be minus with substitutions of lower boundary into the functions. You will get this. You know that e power of infinity will be equals to 0, while e powers to 0 will be equals to 1. Solve this, you will get the final answer here, and this final answer is the one that asks you to prove in this example. These examples ask us to prove that the Laplace transform of hyperbolic cos is equals to this. Again, this can be obtained from the tables of formulas for the Laplace transform. However, the questions ask you to prove the outcome. Based on the formula, you know that the hyperbolic cosine of x can be written in this manner. Substitute this into the functions, you will get this. You may separate the two terms here to become the Laplace transform of the two. Solve this by referring to the formulas of Laplace transform. The difference between this and this is the positive and negative for the constant a. While you're substituting the a here, remember the sign of positive and negative. rewrite it, you will obtain this. Your next step is to combine the two fractions, which the output is going to be like this, and at the end of the day, this will be your final solution.